Question 11, church vault problem. This is where we have a vaulted structure, in other words an arch, with a span of 12 metres and a height h, rise of 6 metres, and the buttresses, the bay width of the arches, are at 6 metre centres. The arch itself we assume is a constant thickness of 200 millimetres or 0.2 metres. The density of the masonry from which it's constructed is 2,200 kilograms per metre cubed, or 22 kilonewtons per metre cubed, and the buttress itself has a height of 10 metres, a width of 2 metres, and a depth of 2.4 metres. And if you follow the hints in the book, figure 2.8.7, 2.8.17, that's in chapter 2.8. And we're working out a horizontal thrust which corresponds to 2.8.7, which is WL squared over 8H is the thrust. Question 11a, and we're going to work first of all about what the thrust is going to be from the arch, which is restrained by the buttress. And we've got a symmetrical section. If we make an assumption that the thrust is horizontal, then we can ignore the fact there's a slight incline, span of 12 metres, rise of 6 metres, and we make an assumption that RH acts on the flying buttress horizontally, and RH from previously is given by WL squared over 8H, figure 2.8.7 for an arch. And we will put in the figures, working out W, and we get 79 kilonewtons is the horizontal thrust at each buttress. So we go now to check to see whether the buttress is sufficient to restrain the thrust. Question 11a continued. We draw out the buttress. Put RH from the previous page, which was 79 kilonewtons, and height of 10 metres, depth of 2.4 and width of 2 metres. So the zone of thrust, we draw our vector system for the forces. We would like the geometric equivalent to be within the middle third, so we work first of all out what W is, the buttress weight. It's 2.4 times 2 times 10 times 22, which density gives you 1056 kilonewtons. So there's our parallelogram of forces. So by the same ratio we can work out what the width, if you like, of thrust is, within which zone, from the, which is 79 divided by 1056 times 10, which gives 0.79 metres. And let's just draw a quick elevation on the buttress, and we split this into three. So the middle third of the buttress is where we're looking for the forces to act within. The middle third is given by 2.4 over 3, which is 0.8 metres. We know now that our zone of thrust is 0.79. This is less than 0.8, which is within the middle third. So by the criterion we've set, the buttress stabilises the arch. Thank you for listening.